Welcome back, students. In the today's video, we are going to see the Poisson distribution. So the Poisson distribution is due to the French mathematician. So his name was Simon Denis Poisson in the year 1837. So it is a discrete probability distribution. So we already know that the discrete probability distribution means it takes finite number of values. The Poisson distribution is a distribution of a rare events. So simply we can say that it is a distribution of a rare events. So the events whose probability of occurrence is very small and the number of times are very large, then we use this Poisson distribution. So if anyone asks when do we use Poisson distribution, then the simple answer for that is when probability of occurrence is very small but number of times is very large, then we use this Poisson distribution. So next we can say that Poisson distribution is derived as a limiting case of binomial distribution when it satisfies the following three conditions. So number one, first condition is here the probability of occurrence, that is probability of success is very small, that means p tends to 0. Next, p is n is very large, that means number of tries it must be very large. Next point is np is finite, that means np equal to lambda, where lambda is a parameter of a Poisson distribution. So if it satisfies the following three conditions, then we say that it is a limiting case of a binomial distribution. So simply we can say that Poisson distribution is a distribution of a rare events. So next, the definition of a Poisson distribution. A random variable is x is said to be a Poisson distribution if it assumes non-negative values. Non-negative values means in the sense it is a positive values. Then its probability distribution density function or a distribution function is given as p of x equal to e power minus lambda into lambda power x by x factorial, where x takes the values from 0, 1, 2, 3 and so on, equal to 0 otherwise. So this is the formula for Poisson distribution. Here the lambda value is always greater than 0 and lambda is the parameter of the Poisson distribution. So it is a distribution suitable for rare events for which probability of occurrence, that is p, is very small and n is very large. So there are some of the examples. See, here we are taking some of the examples. So the example is consider a number of persons born blind in a city, in a large city. So individually being born blind is a rare event. So it is not possible. So here born blind means it is a rare event. That means the probability of success is very small. But in a large city, the total number of births are very more. So n is very large. So as a result, we may get some blind births. So this is an example of Poisson distribution. So here some of the examples of a Poisson distribution. The number of defective electric bulbs manufactured by a reputed company. So defective electric bulbs means some of the electric bulbs are defective out of many. So many means the number of tries are more, but the defective, but the probability of occurrence is very small. The number of telephone calls per minute at a switchboard, it is rare case. It is also a rare case. Telephone calls means per minute. Per minute means rarely 1 or 2. The number of cars passing a certain point in 1 minute. In 1 minute means it must be little one. So probability of occurrence is very small. So these are some of the examples of Poisson distribution. Here the probability of occurrence is very small, but the number of tries is very more. Then only we use this Poisson distribution. So here there are some conditions of Poisson distribution. So they are, number one is the variance. The variable number is a discrete variable. Here the variable is a discrete variable. We have to take only the discrete variables. The occurrence are rare. That means rare events. This is the distribution of rare events. The number of tries is very large and the probability of success is very small. That means it must be close to the 0. That much small it must be. And np equal to lambda. That must be a 5. So these are the conditions of a Poisson distribution. So some of the important points of a Poisson distribution are the mean of the Poisson distribution is lambda and the variance of a Poisson distribution is lambda and standard deviation of a Poisson distribution is root lambda. Parameter of a Poisson distribution is lambda. So all the values will become lambda. That means mean is lambda, variance is lambda, standard deviation is lambda, root lambda and parameter is lambda. Next, the mode of the Poisson distribution, it lies between lambda minus 1 and lambda. Next, the recurrence relation formula is p of x plus 1 equal to lambda by x plus 1 into p of x. Next, the range of a variable is from 0 to infinity. Next, the mean and variance are equal. So these are some of the important points of the Poisson distribution. So now we are going to see some more problems. If the bank received an average of 6 bad checks per day, what is the probability that it will receive 4 bad checks on any given day? So we already know that in for Poisson distribution, the formula is P of x equal to e power minus lambda into lambda power x by x factor. Here he has given lambda equal to 6. So he has given lambda equal to 6 on substituting these values, lambda equal to 6. And he has asked for 4 bad checks. That means x is 4. That means x equal to 4. We have to substitute these values. Then we get the answer, that is 0.133. So this is the answer for the given problem. So next we are going to see the second problem. So second problem is, a hospital switchboard receives on average of 4 emergency calls in a 10 minutes interval. So emergency calls in a 10 minutes interval, that means average, yes, given average. Average means mean, that is lambda. Here the mean in Poisson distribution is lambda. So he has given the lambda. Next, he has asked, there are at most 2 emergency calls in a 10 minutes period, and there are exactly 3 emergency calls in a 10 minutes period. So he has asked the probability for this both. So now we are going to find the probability for that. So for that we have to take mean, that is lambda, that equal to 4. Already he has given the average, that is 4. Average means mean. So the mean in by Poisson distribution is lambda. So lambda equal to 4. We already know that the formula is P of x equal to e power minus lambda into lambda power x by x factor. On substituting these values we get this. So he has asked to find there are at most 2 emergency calls in a 10 minutes period. That means at most 2 calls means P of x less than or equal to 2. That means P of x equal to 0 plus P of x equal to 1, P of x equal to 2. On substituting the values we get answer. So that is 0.2381. So he has said that exactly 3 calls. That means P of x equal to 3. So on substituting these values we get the answer, that is 0.194. So this is the answer. So the next problem is, a manufacturer knows that the condensers he makes contain an average of 1% defect. So he has given an average. Average means lambda value. So he packs them in a box of 100. So that means n equal to 100. So he has asked that what is the probability that a box picked at random will contain 3 or more faulty condensers. So this is the problem he has given. So first of all, what we have to do is we have to find P, that is probability of defective condensers, that is equal to 1%. It is negligible small. It is small. 1% is 0.01. So total number of condensers, those are 100. So we know that mean lambda equal to NP. So NP means binomial distribution mean. So here we can take lambda equal to NP. Why? Because it satisfies two conditions. That is, P is nearly small and n tends to infinity. That means P tends to 0 and n tends to infinity. So we can take lambda equal to NP. Then the lambda becomes 1. So we already know that the formula for Poisson distribution, e power minus lambda into lambda power x by x factorial. So on substituting these values. So now what he has asked is, he has asked at most what is the probability that a box picked at random will contain 3 or more faulty condensers. 3 or more means P of x greater than or equal to 3. That means 1 minus P of x less than 3. That means 1 minus P of x equal to 0 to up to 0 x equal to 2. So on substituting these values we get the answer, that is 0.0803. So this is the answer for the given problem. So the next problem is, average number of accidents on a day on a national highway is 1.8. Average means it is mean. So lambda equal to 1.8. So he has asked at least 1 and at most 1. So at least 1 means P of x greater than or equal to 1, and at most 1 means P of x less than or equal to 1. So P of x greater than or equal to 1 means 1 minus P of x equal to 0. P of x less than or equal to 1 means P of x equal to 0 plus P of x equal to 1. So on substituting these values we get the required result. So it is also similar. So the fifth problem is also similar that of the fourth problem. So next problem is, if x is a Poisson variate such that 3P of x equal to 4 equal to 1 by 2 into P of x equal to 2 plus P of x equal to 0, then find the mean of x and P of x less than or equal to 2. So already he has given that it is a Poisson variate. So we know that the formula for Poisson variate is P of x equal to e power minus lambda into lambda power x by x factor. So now we have to find the lambda value. So he has given a condition. So 3P x equal to 4 equal to half P of x equal to 2 plus P of x equal to 0. So on substituting P of x equal to 4 and substituting x equal to 0, we get the lambda value. So the lambda value is 2, which is greater than 0. So therefore the mean of the Poisson variate is 2. Now he has asked P of x less than or equal to 2. X less than or equal to 2 means x equal to 0 plus x equal to 1 plus x equal to 2. On substituting these values we get the answer, that is 0.498. So this is the solution for the given problem. So these are the problems on the Poisson distribution. So thank you students, thank you very much.